Hi guys, Assalamu alaikum. This is Arif. In this video, we are going to see how we can design a unit which can do both addition and subtraction for us. So first we are going to see how we can do that in system Verilog, and then we are going to see how we can do that in a VHDL program. So this is a system Verilog program first, in which in this design file we have a module named add sub, and it is going to be a 8-bit unit, and it has this S as some output which is going to be 8-bit, and then it has two outputs as carry output and then the overflow output, and then it is going to have three inputs. Two inputs A and B are going to be 8 bits. So after that we are going to use this sub input, and we are going to exclusive or it with each bit of our B input, because B is going to be that input which we are going to add to our A input, or which we are going to subtract from our A input. So that's why we are going to do an exclusive or with the sub bit like this. If you are going to read some theory, you can understand it from there better, that how we design a adder and a subtractor. And after that we are going to add all these, like this A input with this XB input, which is the result of our B input, and exclusive or with this sub signal. And after that we are going to add this sub signal as well, the third input. And the way it is going to work is, it is once sub is going to be 0, we are going to get the addition result from this addition, and once the sub is going to be 1, then we are going to get the subtraction result from this. For more explanation you can read any theory, but this is the way we do it, and we are going to get a sum and carry like this. And after that, in order to get the overflow, we can use this logic, and for this you can also read some theory. And look how we are using here this sums most significant bit, and then the most significant bit of our this XP signal, and after that all this. So this is our complete module, and now I am going to show you its test bench. So this is the test bench program which we are going to use to simulate this module, and this module test bench has this A and B as regs, and then the sub input also as regs, and then some output as wire, and carry output and overflow bits as wire as well. And after that we are calling here our module add sub, which is 8-bit like this, and we are going to use all these wires and regs to map our inputs and outputs like this using positioning. And after that, in this initial block, what we are doing is, we are setting here first of all A equal to 0, B equal to 4, and sub equal to 0. So this is going to give us like the addition during the first cycle. And after that we are going to run this for loop, and we are going to use this random function to change the inputs to our these three inputs, so that we can get different values of our inputs, so that we can check our outputs as well. And after that we are going to give this combination as well. This is the case where we are going to add these two, because sub is going to be 0. And now save and compile this program. Let's simulate this program so that we can understand its logic, the way it is going to behave. add all these inputs and outputs to our wave window, and let's run the simulation. So this is the way we are going to see our inputs and outputs. These are A, B, and sub signals. Here sub is going to be 0, here sub is going to be 0, so we are going to get our addition results here and here. And during this period, once sub is going to be 1, we are going to get our subtraction outputs like this. And this is going to be our carry output, and this is going to be our overflow output. Close this simulation. Let's go to our design file again. And instead of doing the exclusive or on our input be like this, we can instead use a simpler approach as well. So we can skip these lines and we can use here this approach. This is our generate, which we are going to use to run our for loop, and this is going to give us the same result like this. So for loop is going to go from 0 to 7 for 8 bits, and we are doing here the same logic. By doing the exclusive or of this sub bit with this all bits of our B input, we can do something like this to implement this. And also instead of doing this, we have a third approach. In the case of system Verilog, so we can comment out these lines and we can use just this simple line. And this is going to give us the same result, whatever we are getting from here or whatever this for loop is going to give us. So this thing like this. So this is going to do the exclusive or of sub with all 8 bits of our B input, and the overflow bit is going to be like same. So we can save and compile this. Now what we can do is, instead of using this, we can use these code lines as well. This is just another approach. Uncomment these lines. So we are going to define another variable here, which is going to be a wire of 9 bits. First 8 bits are going to give us our sum or subtract result, and the last bit is going to be our carry output bit. So what we are doing here is we are adding these three signals: A, the exclusive OR of this B input with sub input, and plus the sub input. And the first 8 bits of our result is going to give us our this sum or subtraction output, and the last bit, ninth bit, is going to give us our carry output, and then this overflow we are going to calculate the same way. So now let's build and run this program. Go to Testbench. Expand this, and we can see the same and input output combinations. So now I am going to show you another approach, the way we can design our this subtraction and addition unit. So in this case we were using just this plus operator, which is just like we are using an adder to do both the addition plus this subtraction. And now I am going to show you how we can actually use both the addition and the subtraction operators to do the same thing. So let's skip out these lines. We no longer are going to use this signal as well, so we can comment out these lines, and we are going to include these lines. So here what we are doing is we are saying that assign to this result variable the result, but check that if sub is going to be 0, then do the addition of a and b, but if sub is going to be 1, then do the subtraction of b from a using this operator. So we are right now using not only this plus operator but the negative operator like this as well, right? And then again we are saying that assign the result of our first 8 bits to sum this s output, and then the last bit, which is going to be the ninth bit, which is going to give us our carry. We are going to do the exclusive or of our last bit to the sub signal. So in the case of sum, it is going to be 0. So the this bit is not going to change. But in the case of sub is equal to 1, we are going to invert this bit because we want to get our carry output according to our subtraction, not the addition, right? And then this overflow bit we are going to get, we are going to do this most significant bit of our B we are going to take, and we are going to do the exclusive or of that with this sub signal here and here as well. So otherwise this logic is same, just like this line, the way we were doing once we were using this plus operator or just the adder logic. But here right now we are going to use the both logics, the subtraction logic and then the addition logic, because we want to get both results from the same unit, right? So now let's save this program, and now let's compile this program as well, so that we are sure that we are going to get the same results or not. So you can see the same input and output combinations are there. So now we have actually seen that how we can use the adder to design our adder plus subtraction unit, or we can use the adder plus subtractor as well to get our addition and subtraction using the same module unit, right? So instead of using this line, we can also use this line as well, like this. So this is going to give us the same result. So we can save and compile this code. So we are going to get the same results. So now let's flip over to our VHDL program and see how we can do the same stuff using VHDL language. So now we are in our VHDL project, and this is the design file in which we have defined this entity, and this has name add and it is 8-bit unit. So it has this S signal defined as in out and carry out signal defined as in out as well, and the overflow bit defined as out. Then these three inputs like this S carry out we are defining as in out because we want to use these two signals to calculate the output of other signals as well. That's why we are defining these as in outs. I am going to show you this thing later during this program. And after this, in this architecture of this entity, what we are doing here in this begin block, after defining the signal xp, what we are doing is we are going to do again the exclusive or of our b input with the sub signal, because this b we are going to use to either subtract it from our a input or add it to our a input, and that's why we are going to use this logic on this b. On sub is going to be 0, we are going to get the output as sum. On sub is going to be 1, we are going to get the output as subtraction. And after that we are going to add these three signals a xp plus sub xb we are getting from here, and the carry out we are going to get using this logic, right? And the overflow we are going to get using this logic. So this is our complete program, and after that we are going to end our architecture. And now I am going to show you the design of our test bench. And the test bench has a entity test bench, and in its architecture we are going to use this add sub entity as a component like this, and after that we are going to define our signals like this, and we are going to use these signals once we are going to call this entity add sub like this, and we are going to use these signals to map our inputs and outputs using the positioning. And after that, in this process block, the first input we are going to give to A is 0 and B as 4. So we can give the inputs like this as well. Look here, we are using this standard logic vector and these two unsigned like this. So this is the value which we are going to give. Since this is an 8-bit vector, we are going to put an 8 here. Same way value is here and 8-bit vector, so we are going to put 8 here. And sub we can give the value like this. It is going to be 1 bit, so we can first set sub equal to 0, which is going to give us our sum, right? And after that we can change the sum value to 1 because we want to do this subtraction as well. Same way we are going to try different combinations, and at the end we are going to make the sub again equal to 0 because we want to see the sum results as well. So this is our complete test bench program, right? So let's go to our simulation because we have already compiled two files, test bench, simulate. So we are going to see the same input and output combinations. So we see here A, B, and then this S output, this and these are going to give us our sums, because our sub signal here and here is equal to 0. Here it is going to be 1. These are all subtractions. This subtraction result, this subtraction result, this subtraction result. Here the carry output like this, and then the overflow bit is going to set like this. Let's end this simulation. So right now actually we are using the addition or the adder or the add operator to get both the subtraction plus the addition. Look here, we are using this add operator. So it is just like we are using an adder to get our results like this, right? So now what we can do is, actually first we are going to play on this addition logic, and I am going to comment out these lines, and we are going to use these lines instead. So this is just another way using this generate inside VHDL, right? And we are going to do the exclusive OR of our sub input with the all bits of our B from 0 to 7 like this, and generate, right? And we can skip out these lines as well, because we are going to implement this logic using another way, and we are going to include these lines. So these lines can uncomment, and for these lines we are going to need another signal, which is going to be our this signal, and this is a vector of 9 bits. First 8 bits of this vector we are going to use to get our sum or subtraction result in the S output, and then the last bit is going to give us our carry output, and the overflow logic we are going to get like this most significant bit of our A ending with this XP signal like this, and this logic. And also what we are doing here is we are first of all making this A input, which is 8 bit to 9 bits like this. We are adding a 0 here, then we are adding another 0 here, because this is also 8 bits. We are going to make it to 9 bits like this, and plus this sub signal, and this is the way we can do the addition, and we can store all the 9 bits result here, and later we can use that here like this. So let me show you the result of this as well, because everything should be working the same way. So we can see the same input and output combinations. So now let's see how we can do the same stuff using the addition and the subtraction logics, like using the add operator plus the subtract operator. So let's include these lines into our code and keep out all these lines. Command selected. We are no longer going to use this signal, so comment out this signal as well. And now look here what we are doing. We are saying this result is like 9 bits, and then we are making this A which is 8 bit, we are making it 9 bits. This B which is 8 bits, we are making it 9 bits. And then we are saying when sub is equal to 1, do this subtraction. So this is a subtractor we are using here. And else we are saying do the same, make A 9 bits, B 9 bits, and then add both by this add operator like this. And first 8 bits we are going to get the result of our subtraction or addition, and the ninth bit we are going to get the result of our carry out. So once sub is going to be 0, nothing is going to change, and we are going to get the last bit of our result as our carry. But once sub is going to be 1, this XOR is going to invert this bit, and we are going to get the result here. And then the overflow logic is going to be like this. Here we are using this in our overflow, and here we are going to do the XOR of our B7 bit with this sub bit here and here as well. Rest is same, right? So this is our subtractor, this is our adder. Let's save this, compile this, and simulate. Run simulation, and we are going to see the same input and output combinations like this. So this is the way we can use the same unit to do the addition and subtraction using system Verilog and VHDL languages. So thank you guys. I hope you guys have enjoyed this video. Have fun.